When I got recommended Scheme, it actually wasn't my first experience with it because when I was perusing the family library, I used to read a 1.5 Lisp manual.
Welcome to another episode of ArrayCast. My name is Conor, and today we have three panelists as per usual and a guest, which I am super excited to talk to. First, we'll go around with brief introductions. We'll start with Bob, then go to Stephen, then go to Rich. Then we're going to have three short announcements, and then we'll hop into our interview with our guest today.
I'm Bob Therriault. I'm a J enthusiast, and I'm also working on the J Wiki right now, and we're making some progress. Hopefully by the end of February, we'll have a working online way to play around with J, sort of like try APL, but it'll be the J version. So that's what we're aiming for by the end of February.
I'm Stephen Taylor. I'm an APLer from way back, and these days I'm the KX librarian.
I'm Rich Park. I'm an APL programmer and evangelist working for Dialogue Limited.
And as mentioned before, my name's Conor. I am not APL or J or K or Q or BQN developer. I code in C++ day-to-day professionally, but I love the array paradigm and all the languages associated with it. But yeah, that's all I'll say for now. We've got three short announcements. I think we'll go to Rich first, then Stephen, and then Bob, and then we will introduce our guest.
First thing then is voting has started for an APL logo that's vendor agnostic. So there's a little bit of history around what I said there. APL historically has been developed by lots of separate entities who will have used their own logos to promote it. There hasn't been a cohesive single logo for APL, the language, really before. So some members of the community have decided to lead an effort to rectify that and sort of try to decide on a vendor agnostic APL logo. And currently there is a vote on if you'd like to have your say in deciding a short list for 5 possible candidate concepts. For a little more context, you can watch Conor's video, Code Report, APL logo video. He describes things a bit more there. Or to actually go and find out how to vote, you can go to apl.wiki/APL_logo, but there'll be links in the show notes for all of those things.
Dan Baker, the KX evangelist, is currently canvassing interest for a vector dojo. This will be a regular practice area for the Q programming language, and the model is not a webinar, it's not a classroom, but a martial arts dojo where students of all levels can practice with each other and participate and share knowledge. If that interests you, if you'd like to learn more about it or just or got some ideas about what you'd like to learn from it, register at community.kx.com, find Dan's announcement and tell him what your interest is.
And I've got an admission. When I work with people, I often work with them on a first-name basis. So the two guys that I've been working with on the wiki are Will and John. And of course, their last names I didn't bother to find out how to pronounce. In the last episode, I massacred their last names. It's Will Gahate and John Hoff. I've checked with them. This is accurate. And they're also working with Joe Bogner, who I also have checked with. So now I have the pronunciations right. And apologies to these gentlemen.
Awesome. All right. We got last name pronunciations and a couple of exciting announcements. Yeah, the logo. Definitely go vote if you're interested, that is. I am super excited. Anyone that's watched or follows my YouTube channel knows that I'm a huge programming language logo fan. And yeah, it'll be nice to no longer have an orange, 3D cube box, which I sort of stole from Dialogues, the company's website that I've been in sort of place of not having a logo using that. And yeah, the Vector Dojo also sounds super cool. So I will have to check that out at a later date. But without further ado, today's guest, you may have heard his name probably a plethora of times on this podcast so far, if you've been listening to past episodes, is Aaron Shu. Currently works at Dialogue Limited, so a coworker of Rich, one of our three panelists today, and also works with, I think we've had on now both Morten and Gita, which are the CEO and CTO of Dialogue Limited. So for those that you don't know, if this happens to be the first episode of a Raycast that you're listening to, Dialogue Limited is the company that puts out Dialogue APL, which is the most popular version of APL these days. And before working there, Aaron was very well known and is still well known for his work on Dfns, which is a GPU-hosted compiler that compiles APL down to run on the GPU. So I believe you spent most of your time at Indiana University getting your PhD working on that, and then I think still continue to work on that at Dialogue APL as well. And the only other thing I'll say about Aaron, which hopefully we'll get to hear a little bit about, is before becoming a huge APL fan, Aaron spent a lot of time as a fan of another language, Scheme, which I think is super interesting because there's an individual in the C++ community that's super well known, Stepanov, that had a similar path, spent a decade in love with Scheme and then sort of found his way to C++. And I find it interesting when people that are huge fans of certain languages, before that language, there was a language that was entirely different. Scheme is, well, actually, we'll get Aaron's thoughts on how different Scheme and APL are. But with all that said, we'll throw it over to you, Aaron. Feel free to go back to however far back you want to and give us a brief history of yourself, and we'll go from there.
Sure, yeah. And, as excited as you may be, I think I'm also pretty excited to be here because I really like this Raycast and I like what's being done here. So it's pretty exciting for me too. I guess I'll try to keep it brief, but I have been programming since I was basically in middle school. So like I have to go and like chart my experiences back there. So I began basically doing learning programming in middle or early high school and absolutely fell in love with it. And just like that was my thing then. I just kept working on that. And I used to do it on QBasic with I don't know if it was like a 486 or one of these old machines. And that really formed a lot of the pain that I went through. And the fun that I had at that time really formed a lot of my early filters about how I judge a language. And from there, the struggles that I encountered working with QBasic led me into really appreciating what Scheme was able to offer. So when I was struggling around with C and C++, as a teen, trying to figure out how these things worked, playing around with Blender, doing like 3D stuff. Then I discovered the Scheme stuff on the recommendation of a programming mentor. And it like just blew the doors wide open in a way that I had never seen before. And the degree of freedom and liberation that I felt in doing that was something that I could still remember to this day, sitting in the room, working on this going, oh my goodness, this is just, what have I discovered here? This whole world just fell before me and the walls crumbled and all this other kind of stuff. And then I got pretty good at Scheme. And then basically APL was I don't know if you like in the martial arts stories, the histories, the mythologies of martial arts, since we're going with the dojo theme here. And I also like the martial arts, so I have to bring that in. And there's a point at which like this experienced martial artist encounters somebody who's got something else, and then they battle it out, and they realize, wait a second, like my stuff isn't quite good enough here. Like I can't just keep going on the path that I'm going and defeat or learn or master this other martial arts master. And that I was kind of my encounter with APL as I played with APL and went, oh my goodness, what's going on here? And then I started, that started my trek down APL. And I guess that started in 2010-ish. So it was actually probably separated by a few decades for each one, a decade in Scheme, a decade now, I guess, in APL.
And so I guess maybe the obvious question, which we actually spent our first episode, I think, talking about, and we try to do a good job asking all of our first-time guests on, is what is it that, drew you to? So you said there was a war at some point or some battle between Scheme and APL, and you were holding the blade of Scheme and someone else had the bow and arrow of APL, or I don't know, whatever weapon represents APL. And
It was probably more accurate to say I had just uncovered this dusty old tome.
Okay, so there was no battle. You were.
Yeah, it was more that the battle was imagined in my head after uncovering these tomes, because it was a little bit like uncovering an archaic, like the APL of 2010 is not the APL that we have today.
This is very true. Very true.
And the ecosystem is not the same and things like that. So it really was more of a uncovering the Ring of Power or something like this, going into the libraries and trying to peek into things. It was a lot more like that.
So what was it about, and maybe if you want to contrast sort of QBasic versus Scheme, because obviously, you fell in love with Scheme. So, what was it about Scheme that spoke to you? And then what was it about APL that really made you fall in love with that language and then, switch from one love to another love, basically?
Yeah. So when I learned computer science as a kid, I basically started with sorting algorithms. And so what we did is we went through each of the sorting algorithms and we had to design flowcharts to implement those sorting algorithms and then implement the flowcharts inside of QBasic. Now, as a young kid, I had no concept of a lot of the ideas that would have helped me do that in QBasic, right? And so when I got to the radix sort and I tried to use a type of recursion inside of QBasic, well, I hit this tiny, tiny stack limit on the system because I didn't understand how QBasic's different subroutine calling mechanisms work and all that. And so I hit a wall. I couldn't make any progress on doing a lot of these algorithms that I wanted to do or using a lot of these programming techniques. And when I got recommended Scheme, it actually wasn't my first experience with it because when I was perusing the family library, I used to read a 1.5 Lisp manual. I had no idea what it was saying, but I just looked at it and was reading it because I loved what I was reading. And I didn't really know what I was reading. I was just reading it. And so visually, I had already been sort of attuned, I guess, to what I was seeing. But I can remember pulling out that little slim white Lisp 1.5 manual, or it looked white to me. It was probably more like an aged cream at that point. But when I downloaded MIT Scheme and started playing around with it, I eventually switched over to Shea Scheme. But I remember going, all right, here's the test. Can I get this radix sort thing working in a way that I feel good about the code? And at first, it was, again, a brick wall. I had no idea what I was doing. But I had gotten onto some IRC channels at that point. And I remember Taylor Campbell actually was very helpful during this time. And I played around with it. And then it clicked, like the data flow in a functional style through the procedures flowing through the system and that forming your code. And then I wrote it and I looked at it and was like, oh my goodness, I don't have to worry about all sorts of stuff. Like it was the system removed the limitations for me. I was no longer, all I had to do, I felt like all I had to do was think about my problem and then express it in this particularly elegant universal way. And that held on for a really long time because I think it was Aziz Gulum who told me this first, that Scheme was like the language of least restriction. And I still think that kind of holds true today, is that there are very few languages that let you do as many cool things from a computer science standpoint as you can get away with in Scheme, right? You can go really low level, but you can also go really high level in Scheme and accomplish just about anything from a semantic standpoint, right? And you can build macros on top of macros to build whatever language you want. And that flexibility was extremely powerful. And so I used it to build like a hygienic literate programming system. The Shea Scheme modules were really cool. And of course, at this time, I was in one of the great seats of power of Scheme, right, at Indiana University, with what I consider some of the greatest minds in Scheme there. So of course I had a lot of advantage in terms of what I could do there and what I had access to in terms of experience to play around with the Scheme language. But at the time, I was also really interested in exploring parallel systems. And the parallel systems we had talked about all sorts of parallelism in the Scheme community. And Kent Dybvig, who I consider one of my early mentors, he had written a dissertation on trying to automate parallelism inside of Scheme and the difficulties around that. And other people at IU at this time were really working on work-stealing schedulers for task threading. And I had read this book, I think I've still got it right over there, on concurrent programming. It's one of the classic formal texts on concurrent programming and using a axiomatic semantics to reason about concurrency. And that book highlights the difficulty of the formal logic around actually talking about task parallelism and these other kinds of parallelism. And at that time, alternatives were getting a little steam that people were exploring, like these data flow models. And all around this point, I had started needing to explore things outside of Scheme, and I was playing around with them, but Scheme was still my base. And then I really, after X number of years in the language, I started saying, well, what else can I learn? What am I going to add here that's going to be a little value add? And we had always scared our introductory students. It's some of our, what do you call labs? Some of our early CS labs with a line of APL, the game of life, saying, don't be afraid of Scheme. We could be having you program this. And of course, it actually kind of worked, because they saw this and like, wait, you could really do that to us? And so I had known about APL, but only from that, it's the crazy symbol language. And then I started saying, well, I guess I really don't know what this language is. I don't have an idea of it. I don't have a sense of it. I have a lot of opinions. I have a lot of, basically judgments that are made without enough evidence. And so I started going in and saying, well, what is APL actually? And I started reading about it, and then I started playing with it, and I downloaded APLX, and I started trying to solve some problems with it. And unlike with Scheme, where there was this wall that I had to kind of play with, there was a bit of a wall with APL, but not so much, because I was a lot more experienced at this point. And when I started playing with it, it was like, again, these walls falling away. There was a certain sort of, I guess it's there's not really an easy universal analogy to it, but it was liberating in some of the same sense, except it was totally different than the sense I got when I was playing with Scheme, right? When I was working with Scheme, I was building something. And when I was using APL, I was writing a description of a solution. It was a very different experience. One was like architecture, and another was like fiction writing or something like this. There was a total paradigm shift in terms of how I approached problems. And of course, with every other paradigm that I had received, I could just re-implement it in Scheme and get all the same values. So I thought, okay, great, I'm going to take all of this and bring it into Scheme. And it didn't work. Like I tried, and every single time from various angles that I tried to implement APL in Scheme, it lost its magic. It was no longer the APL that was giving me the experience that I wanted, and it wasn't any better than what my Scheme solutions were. Adding the APL for me into Scheme didn't net me the kinds of benefits that I expected, having already experienced APL in the native form. And I was really confused by that, because that had never happened to me before. That's what sort of the unpacking of the tome, right? Is I went in there like, wait, what's going on here? And like, in some sense, the martial arts were just a little incompatible. And I didn't understand why they were. I didn't understand why APL was the way it was. And then it took me a long time to unpack that. And eventually I discovered that it was because of syntax. It was because Scheme is so driven by semantics and a freedom around semantics. And APL, in the large way, constrains those semantics. But by doing so, gives you massive freedom in terms of the expressive power at a syntactic level and in a different dimension. And I couldn't get that by trying to mimic the semantics of APL inside of Scheme. The only way I could get it is if I basically re-implemented the syntactic APL in Scheme, and I would have had just another APL interpreter at that point. And that's when things really just started taking off for me.
All right, there's so much I could ask and say.
Yeah, sorry, that was a bit of a rant.
Actually, well, I'll pause because I'm pretty sure our other panelists have a couple questions. I think I've seen a couple people jotting notes, so I'll throw it to Stephen and then we'll circle back. But yeah, this is awesome.
I can't resist this one. I hadn't realized how deeply you were into Scheme in your background. So Whitney's often described K as a blend of Lisp and APL.
Mm-hmm.
I'm wondering, what was your experience in encountering K and Q?
I immediately saw how Whitney leveraged his background in Lisp. I think anybody who's done a lot of Lisp will see huge amounts of underlying similarities in how Whitney adjusted the semantics of APL to have more of a Lisp flavor while like sort of keeping so it was almost like Whitney took the opposite direction. I was trying to take APL and bring it to Scheme. And I think Whitney had a lot more success precisely because he, in essence, took the semantics of Scheme in some level, or took some of the aspects of the semantics of Scheme and merged them over to the APL side instead of going the other direction. And I think his net worth would demonstrate that he was significantly more successful at that than I was at going the other direction. And I think the way in which he chose to simplify it, I think it was really clever. It was really clever. Now, whether I personally agree with that direction moving forward, that's a different question. But in terms of the connection, the Lisp K connection, I think it's pretty it's pretty straightforward if you know both languages or are familiar with both domains. There's a lot of overlap there.
And just for the listener that, once again, this could be the first episode, Whitney refers to Arthur Whitney, who's the creator of all the K dialects, which K4 eventually became Q, and is now working on Shakti. And you could say that he was a protege of Ken Iverson, the creator of APL.
And he was also a midwife for J, because he was the one who wrote the original, I think the original macro that Roger then worked from and extended into J. So.
Yeah. What is that wiki called? It's called the J incunabulum. Incunabulum. Yeah. I have no idea what that word is, but we will link it. And it's actually, because I had spent some time on the J source. When I first looked at it, I was like, oh my goodness, that's crazy. But then after having spent some time on the J source, it's actually not as impenetrable as you would think. Like, it looks just as like at a glance, it's just like a single page of text and everything's formatted oddly. But I think you can see like, J iota or something. And if you're familiar with what iota does, like it's just a loop it's not as impenetrable. It's just a bunch of macros. And it's worth more than just a glance if you're curious. For sure. Yeah. And I will try and find somewhere too. There's a document online. I can't remember if it lived on KPark, which was a website sort of dedicated to K at one point, but it was like notes from Arthur Whitney of like APL or K versus Lisp. And sort of, it was just like a short list of notes that, he was saying, in APL we have this, and Lisp we have this, or back and forth, or K. And it was a short document, but definitely interesting read.
I guess it makes sense to qualify this as well. As when I was doing my PhD, my minor was in HCI with a focus on education. So a lot of my study class work that was not heavy CS theory was all in UX design theory and user interactions and how you teach people things, and a lot of the psychology around that tech interaction. And so a lot of my perspective is deeply colored by the concept of programming language as a human-computer interface, if you will.
Yeah, maybe we should talk a little bit more, because I think you have some super interesting thoughts on that, like how you said it took you a while to grok what it is about APL, and a part of that is the syntax, it's the notation. And I've also spent like a ton of time trying to figure out, does the Q model, where they've wordified things, even if they're short words, is that just as expressive as having single Unicode symbols, or even the 2-character ASCII digraphs in J? And yeah, there's always something about the single Unicode symbols that, like, it's the closest thing or analogy that I've come up with is like, imagine trying to turn an algebraic expression of, parentheses, 1 plus 2 times parentheses, whatever, a bunch of stuff. And then you replaced the plus and the minus and the division with, in the best case, ADD for addition, SUB for subtraction, but or in the worst case, the actual full word. And I was even just looking at some Python code the other day that was basically, you can import from an operators module 3-letter symbols for the operations, add and sub. And it took me like a good minute to realize that SUB stood for subtraction. And so just there's something so expressive about that little mathematical algebraic expression that replacing the binary, operators plus minus with words, there's just some level of obfuscation that I think is introduced there. And it's very hard to communicate what it's like if you can read APL. At least for me, it's hard to communicate the power of reading something so terse, which is not terse in a bad way. Terse is a concise way of expressing, a lot of information. Anyways, interested to get your thoughts on sort of that aspect. Yeah, the notation as a tool of thought, if you will.
Yeah, and for me, I always go back to, if we're programming for computers, then it doesn't really matter on some level. If all our job is to tell a computer what to do, then that's a really different ballgame. But we're not really doing that. We're really trying to communicate to people, whether that's to our future selves or whether the point of a programming language is to enhance our ability to communicate to ourselves and to other people an idea. And otherwise, we'd all just be using assembly at some level, right? It's our ability the programming languages are a tool for us, not a tool for us to drive the computer necessarily. It's really all programming languages, I think, have as an ideal some way of empowering us to be able to think about more complex issues around computation. And when you get to that, then you have to think, well, when it comes to human formal language, when we think about what are the innovations and what are the general trends that you see over the history of humanity in where they're able to leverage their minds the best using external linguistic tools. And I think the trend you see is always towards this natural evolution of a very verbose language, which represents a lack of understanding around a concept, towards more and more refined terse language, until you get eventually some form of expressive notation, which encodes that knowledge in a very direct, immediate way that is more easy for the human mind to manipulate. And the best example is mathematics, but you can find this in a lot of different domains. And these, even if you wanted to, you look at things like bullet journaling, right? As a human journaling practice that a lot of people take up. Part of the benefits of the bullet journaling system is its notational conveniences around the metadata associated with a given task inside of a journal. And the same thing with mathematics is the brilliance of algebra is the Plato-ness of it. It's the manipulatability, that capacity to rapidly explore an idea and make it easier to think about how you would explore it. So when you look at an algebraic expression, it takes training to see how you manipulate it. But once you can see that, you start to be able to do things in your mind and on pen and paper, or even on a computer, that you wouldn't be able to easily do or easily perceive without that notation. And I think that if we ignore the current very small window of history we have around computer science, you'll see, I think most people will agree that most human linguistic practices tend towards something around that nature, even in scientific communities, right? When we have lots of scientific papers, there's usually a diffusion of terminology, a spread of ideas. They all build up these infrastructures and architectures. And then there's this grand unification that occurs where the terms get simplified. Everything gets, people start recognizing that these are actually the same thing. And over time that gets refined into a tight, neat ball of concepts and vocabularies and syntax and ways of thinking about it and frameworks, and then it has another diffusion. And that I think grants some of the strongest evidence in my mind towards a terse direct notation as the the thing we should be aiming for eventually in a programming language. And I think APL is moving towards that it's, for me, the APL symbols represent that mode of thinking better than the other programming languages. Yes.
When you mentioned that in the notation, I guess one of the advantages that APL has is when you look at mathematical notation, there's a certain amount of it that's evolved. And as a result, you have all these arcane symbols and used in a variety of different ways. And sometimes when you have disciplines hitting each other, you have a real confusion as to what they actually mean, because the same configuration in one area will mean something else in a different area.
Right.
And I guessing one of the advantages APL has is it started from a point at which a lot can be expressed consistently across the language.
Absolutely. Yeah, I think consistency is really important. But I mean, as a schemer, I would say that, right?
Yeah. There's something about the regularness too of APL that, like, it was sort of similar to when I traveled abroad and I learned Chinese. I started to realize some of the ridiculous things about the English language that, like, I'd never realized until I learned, like, there's a bunch of them, and I'm not going to turn this into why English sucks and Chinese is awesome, but, like, probably one of the best examples is, like, in Chinese, when you say one cat or two cats, like in English, we prepend or whatever, postpend, whatever the word is, an S to the end of the word when you have a plural. But, like, as soon as you've said two, you know that there's multiple cats. Why are we modifying the noun? And in Chinese, they don't do it. You've got, your object, and then you just say one cat, two cat. You don't need to have this extra stuff that's unnecessary to communicate. And, like, I didn't realize that. And a lot of languages, they have plurals of, there's the singular and then the plural. Chinese doesn't mess around with that. And, like, it was the first language I learned. Like, I learned French in high school as a kid because I'm in Canada. So it's one of the languages you have to learn. And I was like, oh yeah, that makes sense. What are we doing over here? Like, and so the same sort of thing with APL is that, when I discovered the min and the max glyphs, I was like, well, why did we stop in mathematics at, like, plus minus, multiplication and division? Why did we give binary infix operators to a set of common binary operations? But why did we stop at min and max? And then those are still prefix spelled out, like, and then you see it in APL and you're like, of course, like, why don't we just tell the math people so we can stop? It seems arbitrary that a certain set of binary operations are infix, some of them are prefix. Then you go to exponents and we're doing superscript. Like, it's just like, what are we doing here? And in APL, it's way, way, way more regular.
Yeah, it's more regular. But like, there's another aspect of that, which I think is what part of the institutional momentum that happens with mathematics, is that part of the value of something like this is not just in the regularity, because you've got Scheme that has regular syntax as well. It's in the predictability of the vocabulary. So I think it's the value of the shared core. So when you're communicating with other people, it helps if you all don't have to define all of your terms in advance. Everybody has a shared context. So that's what makes, like, some of it, to use the Chinese analogy, some of the early Chinese classics are so elegantly phrased, partly because they omit so much data, because they assume that they're working towards a literati that a scholarly class at the time, who would have already been expected to have memorized and understood a whole set of literature from which you can then pull. And because everybody knows that literature, the way in which you can write is very different. You can play games, you can play these linguistic games that you can't in other languages that have to be much more verbose in setting the stage.
Go ahead, Bob.
So is that, when you use a line of APL to threaten students, is that what's going on there? Is it they when they see is that opaque line, they don't have that background. It's just like, oh, this is, or when Conor was talking about looking at the source and going, well, do you think it's impenetrable? But then you stare at it for a while and you gradually can see the patterns. Yeah. Is that what's happened with APL when we're talking about trying to teach people APL? They're going, this is impenetrable, but it's because we're packing so much on the front end. Is that what's happening?
We're showing them so much at the front end, I think. So it's Wow, we're ranging over a lot of topics, but it's human psychology, right? You've got like the when you're looking at reaching an outcome, right? Your brain has to make a planning assessment to say, how can I get there? And it makes a heuristic judgment of, is this accessible or not? Are there roadblocks in the way? Are these roadblocks too insurmountable? And the more danger and risk it sees in that, the higher your stress response is at the beginning, right? The more fear and resistance and avoidance you encounter if you don't know what or how you would approach a given space. So the more foreign the thing is, the more fear you're going to have around it. And so when you present something like Scheme, it looks scary to it because it's full of all these parentheses. It doesn't quite look at what you think a programming language should look like. But then when you compare it against APL, and suddenly you see this one line of crazy alien symbols or whatever it is, you really trigger an early student's sense of like, oh no. But ironically, by doing that, then you step back and now Scheme is less scary. And so that relative experience changes things. Now, whether that was a really good thing for us to be doing in our labs for the computer science department, that's perhaps up for debate. Like that might not have been the best approach, but it was certainly a fun approach. And I think it wasn't necessarily so detrimental as to ruin the students. But I do think that happens a lot, right? And this is part of the third leg of this triangle is you've got your regular syntax that's consistent, you've got your common vocabulary, but you also have experience in using it. And that's like, this is something people often don't quote from Iverson's Turing Award lecture, is that he says, we believe this tool is extremely useful, despite the fact that you need to become a little bit of an expert at working with it. You need to get experience. You have to actually become competent in using it to make it valuable. And that's the truth for a lot of powerful tools is you do need to learn what you're doing with that system in order to really feel comfortable with it. And in exchange for that sort of upfront learning curve, you get a lot on the tail end, but you have to accept that you might have to embrace slightly different approaches right now. Like touch typing, for instance, that's also a similar skill.
So I have a couple questions, but one of them sort of stacks well on top of what Bob just asked. And I thought about this earlier that, it's very funny or ironic, choose your word, that, at one point you were scaring students as a kind of joke. And then basically due to your curiosity, like you're a curious person that's just trying to put tools in their tool belt or different blades in their, dojo or whatever.
Seeking the hidden knowledge. Yeah.
Yeah. So like, it's basically your curiosity that took you to a point where, especially pre-tryapl.org and you had to go download APLX. You're a very curious person. So you overcame sort of the scariness of this language or the alienness or, what we've been describing. Yeah. What is like the success of this kind of language dependent on people being curious, or is there a better story? Because, we all know of the sort of the pushback that, people see these glyphs and they say, oh, 2 orders of magnitude change the way you think, and notation is a tool of thought.
Right.
But really, like, it was also my curiosity that, like, I had heard about this really cool language on a couple podcasts and finally did a deep dive and was like, holy smokes.
Yeah.
But is it just that we're going to collect curious people over time, or is there a better story for, encouraging folks that like this, it's worth your time to look into?
So I can say yes and no. But so given that I think part of my mission is sort of to change the perspectives and the costs around what it is to experience APL, I think when I started doing the APL, I guess in modern terms, it was for the memes, if you would, right? Like I was basically a meme at some point, right? And when I went from, oh, I'm playing around with this crazy archaic language to, hey, this has some stuff in it in my academic circles, it was, you're absolutely like crazy. You have lost your rocker. We're going to hear that you're in the next asylum somewhere kind of situation at that time. Like it was just not even on people's radars. And then I've still got the a very embarrassing, very poorly presented video on YouTube about me expressing Intel's concurrent collections semantics model in APL on a whiteboard at an IUPL Wonks talk in the early 2010s, I think. And it was a dumpster fire. It was an absolute dumpster fire because I went in there and, you know, I didn't lack for enthusiasm, but you could tell everybody's face was just like, what are we seeing here? Is this guy for real? What is he doing? Does he expect us to, like, I mean, has he just started having a seizure? Like, there was this collective incredulity that was so authentically incredulous, right? It wasn't just like, oh, you use Haskell, you're so edgy kind of thing. No, it was like, this can't be real kind of thing. But over time we've progressed from that, right? So it starts with, oh, there's a crazy mountain man out there. And then the crazy mountain man comes and actually builds a monastery. And then suddenly, like, people go to the monastery and say, hey, this is pretty cool. And then, like, people start doing things, right? And at that point, and like, so one of the things that I've tried to do, and I think a lot of the people who have pushed APL forward, like this arraycast and things like that, is that we try to unpack what it is, explicate it a little better, make it a little bit more accessible, and bring it more into the range of, this is something that's not way off on the mountains. Bring it sort of into the towns and the villages, if you will, and make it accessible to people who can start to see the value. And at that point, it suddenly, now if you're curious, now the curious people start to get into something like this, and they start playing around with it and they start looking at it. And in a lot of ways, I think we're on the boundary between curious and inherent attraction, or inherent value proposition. So I think we still are at a point where, unfortunately, a lot of the most value for a lot of people is coming from curiosity and the satisfaction of that desire to learn and being curious. And that's part of what draws a lot of people in. And so a lot of people still can't necessarily see or believe, like, this is something I need to use because I can see that there's value here, and I don't care if it's weird or strange or something like that. I want it, right? I don't think we're quite at that point where we can just sort of say we've pretty well established that message. But we are at a point where it has respect. I think it has a very strong degree of respect now that it didn't have 10 years ago. And it has the ability to provide something to the curious people and the people who are really early adopters, in a sense. And then I think as more and more people get into this from the curiosity standpoint, eventually I think what you'll hit is a place where people go, oh, this is something I want to know if I want to get a little extra advantage or something like this. I want to know this. And then that shifts from curiosity to I'm picking this to extract value for myself or for my company or to get a competitive edge. And then, ideally the stage from there, you become the de facto standard. And then everybody has to try to find some new competitive advantage because everybody's using it. But that's, if ever, that's down the road. I think we have to start with the curious people and then move into other places as we refine our ability to express ourselves.
Bob?
Do you think that's part of the problem it traditionally has had in academia, is that you were talking about the fact that you almost have to become an expert to start to appreciate the language. Somebody who's not an expert, who is a professor or has a stature in the community, they may not want to go back to that beginner's mindset to learn what they need to learn to be able to become expert at it. Is that one of the things that holds it back?
In academia, I'm going to say no. In industry, absolutely. Absolutely in industry, I think that's the case. But I don't think that's why, at least at IU, this was the case. We had a lot of curious people at IU, and we have a really strong PL department that uses a lot of languages. And so having this new, cool, crazy, we have a language, what's his name? He was, I'll think of his name, but his whole dissertation was on a programming language designed to be entirely reversible so that all computation could go in both directions. so that it could be hopefully modeling the chips for various types of reversible computing architectures that were being designed, and like quantum stuff, right? So there was no end of people willing to go with really off the wall computational models to play around with. Roshan James, that's his name. So you should look up his dissertation on his reversible computing language. And so the curiosity was there. The problem is, where is your focus on value in terms of where do you extract your scholarly publications? Where do you extract, how do you publish? How do you do something new? Where's the novelty? And it's novelty that I think was the hard thing to see in APL, because everybody had seen APL as the language that had already been unpacked and explored in the 80s. And the reality is that a lot of computer scientists right now are just rediscovering what was in the 70s and the 80s. It's this cycle because so much knowledge was lost in a sense. And so they're rediscovering all of these ideas and techniques and tools and having to figure out what works and what doesn't work and why. And the APL language to these academics, it was like, oh yeah, we did that back then. And it was sort of like a closed case, a closed book. But they didn't get the message at the beginning of what was truly novel about the language. I think that was the failure, is that the research that had been done at the time didn't really address why the language was worth continuing doing research on, especially after the additional innovations in the computer science theory. Because APL from a semantic standpoint is as close to trivial as you can get inside of a computer science program for a real practical programming language. It's probably one of the simplest that you can find. What is really unique about it is what happens when you work with that and you actually apply it and what you see out of it. And if your focus has been on all sorts of semantics and you've been trained that syntax doesn't matter, which is a lot of how people grow up thinking in the computer science research communities, is that syntax really, it matters, but it's so much a matter of taste that when you're publishing and you care about novelty, you just ignore it. You know, you use the standard syntax and you go do your novel semantics work. And I think that, you know, there are small tweaks here and there that people recognize as syntactic innovations, but you don't publish on syntactic innovations. You slip a little syntactic innovation in your paper that people will start using, and then you work on your semantics. And there's not a lot of fruit to be gained by trying to alter APL semantics too much, in my opinion. There's certainly some. There's definitely some fruit there, but not in the way that the computer scientists would need to care about it in academia. So they were basically just missing, where's that novelty coming from? And it took a lot of work actually with my committee to convince them that what was happening here was something that was worthwhile.
Yeah, there's a talk that we'll get in the show notes that I watched recently, because I think it really captures what you're saying nicely. And it was a DevOps talk talking about Java, and they were referencing a quote from Rich Hickey, or maybe it was Stu Holloway, but someone from Closureland, about essence versus ceremony, and how a lot of, like, and the example that they were showing was how to get started with, you know, Java. And like, it's like, okay, well, just like, let's do a little hello world program. And it's, you know, classically there's, you know, public static, you know, argv and all this noise before you even get to like the system.out.println and all that stuff. And compared to some other language that's, you know, newer, where you can just go print parentheses, you know, hello world. And it just is the barrier to entry is so much lower. And, you know, that is what, when I was watching that talk, I was just like, oh my God, yes. Like that's so much of what it is in APL, and just array languages is it's just, there's no ceremony. Like it's just, you want to add up a list of numbers, you know, plus reduce, you're done. Like it's the closest to just like pure essence, with zero ceremony whatsoever that I've come across, with different programming languages. That is,
I would say it's the closest you can get to the closest I've seen to a true general purpose removal of ceremony. So there are lots of languages that do a really good job of removing ceremony in one very narrow niche and one very specific domain with a specific set of vocabularies around a specific problem. But in terms of having a single language that removes the need for ceremony across so many domains with the same set of tools, the same vocabulary, the same syntax, the same architectures. I don't think APL has been beat in that department.
Do you have an example off the top of your head? What's like a narrow one with that's not general purpose?
SQL is pretty good.
Okay, yeah, that's good.
Yeah. SQL is one of the classics in terms of the classic success stories of a language that removes massive amounts of ceremony around a particular programming paradigm that people want to interact with. And it's been very successful, and it achieves what it's trying to do very well, especially if you can stick your problem into pure SQL. But of course, what happens when your problem doesn't really quite match your RDBMS relational model that you need, and suddenly now you're having to inject direct functions into your PostgreSQL database, or you need to start thinking about the ordering and indexing operations that are going on, and you start adding extra things that you have to now expand on the language and do things. So it's a very narrow, limited focus, which is why the DSL works so well. It just so happens that APL found this like DSL that is way more universal than people I think originally gave it credit for.
Yeah, no, this is great. I was just about to mention that. So at the end of one of your, I think it's ICFP talks, or maybe even it was like basically the whole ICFP talk, you did sort of just like a live, like throw me a problem and we'll solve it, because that's one of the criticisms is that, people think of APL, they think of math, and they just, it's just matrix operations. Yeah. And the point being is that like, no, you can do yes, it does very well at matrix kinds of things. That is what it was designed for, but it's also very general purpose. And so, a bunch of people sort of from the crowd, you weren't like, you weren't given a list of these problems beforehand and then you cherry picked a few. Right. Literally just people from the crowd would throw out some problem and then you'd live code it like right there. So we'll put a link to that as well.
That was in Functional Conf, I think, a couple of years ago.
You referred to a talk earlier, so we should mention you're a prolific speaker in that you've got, I don't know how many, at least on your APL wiki page, I think there's roughly 20 plus talks across different conferences. I'm not sure if you've got even more, but are there, because you were talking even earlier about sort of something that sounded similar to sort of the idioms versus libraries, and you've got a talk that talks about sort of, there's a list of, I think, 8 things that you're classically sort of taught in sort of, the C++ Java land. And you have to change the way you think about sort of reaching for libraries or modules when you have APL. So I'm not sure if you want to talk a bit about that, but even before you do that, like of all the talks, we don't want to overwhelm our listener and say, I just go listen to all 30 of them. Do you have like a, couple favorite that you would plug if you, and I guess it's, a lot of them talk about different things. So I'm not sure if it's like, if you're looking for just an intro, this is the best talk, or if you're looking for what I think personally is my favorite talk.
I think it's not helpful to point out my favorites because I'm weird and the things that I like don't necessarily correlate. Like I've had to accept that I'm a weirdo and a contrarian and things like that. That's how I make my living, I guess. So I guess the ones that appear to be the things that people say are the most interesting or helpful or most thought-provoking, I think the ones I've got the feedback on would be, you can go ahead and read the dissertation. That's one of the, if you want the sort of single document that lays out a cohesive step-by-step argument in a non-traditional APL domain for APL, you can read the dissertation. That's a GPU-hosted compiler for the data parallel language, or a data parallel compiler for a GPU language, or something like this. I can't even remember my own. There we go. Okay, hang on. A data parallel compiler hosted on the GPU. There you go.
Oh, that's a whole book there.
And the other talk was, does APL need a type system? And the design anti-patterns and patterns, design patterns for APL. I think there are 2 versions of that talk. One is the dialogue talk, and in that talk, I added some discussion of APL style. So I spent some more time talking about the different styles and ways in which people write APL code at the end. That's available both as a Sway presentation and as a dialogue video. And then at Functional Conf, I gave a different version of that talk where I emphasized more of the usability questions. So I included more research citations from early research into programming language usability papers that I think Mosley and Mosley's the Turing tar pit paper, but some of these other guys that did some early research, and a lot of that came out of the 80s because people, I think, reached a point where they didn't have the technology to do the research much further in it, and it wasn't getting the results they wanted. But yeah, so those two talks, I think, one or the other, depending on which one you're more interested in, I think they overlap mostly in what they say. So one or the other would be fine. And those three tend to be the ones that I hear people discussing the most, more or less.
Okay. Yeah, that's good. We'll put links to all of them, but yeah, and I can highly recommend. I can't remember at what point I discovered your talks and co-Dfns when I was falling down the APL rabbit hole. But it was very cool because a lot of the resources they're specifically at some dialogue webinar or conference. But then at some point I stumbled across, I was like, oh, look, there is actually someone at a non-APL specific conference talking about APL. This is awesome. Yeah, a lot of the times your talk style, it's trying to get people interested sort of from different angles. It's like, I thought that the idea of, just throw me a problem and like I have the confidence that I can solve whatever problem, like it text parsing, blah blah blah, like let's just like you think APL is for this, but like that's I had never seen anyone, like I've seen live coded talks before, which are always very impressive. I've never seen a live coded, but like I don't know what I'm gonna live code, you just tell me, like that is very, very ambitious, and I just thought it was such a great, like regardless of the language, I think that's such a cool idea.
I mean, so to be fair here, maybe a magician should never reveal his secrets. But
here we go. It was all staged.
No. So like one of the metaphors I use when I talk about my my work is that maybe I'm supposed to be like a wandering apostle of APL, right? And if you think about what an apostle does, they provide a bunch of principles and a bunch of things. They get people to think about what they're doing and how they're doing it. But you also have to sort of perform miracles, right? That's part of being the apostle, is you're supposed to kind of perform miracles. Or the other analogy is the magician, right? When you've got something that people don't understand, you have to find ways of unpacking it. And one of the ways you can do that is very academic, but it doesn't explain why you care to learn this thing. But if you start with the beauty of whatever you're doing, and you start with this beautiful thing that people can admire, I think you're better off. And so, that's always been my perspective, is I want people to appreciate the experience that they can have, and what you can gain from working with this. And so that idea of the live coding and things like that has always been a part of allowing people to see underneath the curtains a little bit, because they get to see how I'm approaching a problem and my thought process that goes on behind it. So I think it's educational, but also it's fun, right? It's just fun to play around with this stuff, and they get to see things that they might not have already seen. It's a good way to target stuff. But I have been doing programming enough, and I've done enough different problems that I have a lot of confidence in my ability to think about programming problems. And so part of it is that I kind of know my audience. And so I know that my audience is going to give me a certain class of type of problem, right? It's just like, it's going to happen. And so within that space, I'm relatively confident within those domains that I know people are going to give me. So it's not absolutely any problem anywhere that I have to deal with.
It's more like a cold reading.
It's much more, like a cold reading, or, you're in essence, the range of problems that I'm solving, it could go really wild, but there's a curve around where I'm likely to get those problems. So the risk there is relatively low. And even if I did get a wild problem, that would be really fun, because the end result is really about showing how you can play around with these things, not necessarily proving that, not necessarily me coming up with an optimal solution right away. And so showing how APL allows me to think and work, I've actually found has been more illuminating to people than just showing these perfectly crafted APL solutions. And so when people sit down with me and see me working on my compiler, for instance, they go, if they have worked on a compiler in some other domain, they go, whoa, how can you do all of this stuff just here? Because I have so much facility to just play with any aspect of my compiler at any moment. And I can just explore, and I can walk around data in ways that I can't in other languages. And I can try so many different things. When we talk about the like agile and the value of incremental iteration, the scheme in the REPL, like one of the grand things that people discovered is the value of the REPL in these languages, because it lets you keep trying things. And then one of the things, that they discover is they think they got this huge advantage in the REPL, and that's really true. But then when they go into like an APL session, this is like a REPL on steroids, where because the language allows me to just play so quickly and type so quickly, it's the difference between somebody who's hunt and pecking on their keyboard and somebody who knows how to touch type. The difference is night and day, because now I can just start experimenting and iterating on that REPL so much faster and see things in ways that are like, so when I'm looking at trees in Dfns, I can break those trees down into so many different directions, dimensions, things. I can see links. I can ask like SQL type queries over my tree. I can visualize the tree, upwards, downwards, sideways. I can go into the tree. I can subdivide it, and I can do it all in like one line of code each time. And I can just play with that stuff. And to do that, you just have to say, no, I can't do that. I have to solve or debug my code or figure something else out to write my code in another language. I can't play that way as easily in another language. And being able to live code, I think, at a presentation is a part of showing that and demonstrating that, because you can't manufacture that experience very easily. You have to do it live. I think you have to do it when you're specifically unprepared.
Yeah. The word play, we'll throw it to you, Stephen, in a sec, is I feel like it comes up again and again. Like I've described being in the REPL as feeling like you're in like the APL, ride or IDE that comes with Dialog APL. It's like being in a playground. It's like the ability, like in my head initially when I'm solving some problem, I'll think, oh yeah, I could go 4 different directions. I could go for like a filtering compress approach. I could go for this. And I know that like in the next 10 or 15 minutes, I can explore those all super quickly. Whereas like if that just doesn't happen in C++, like my day-to-day language. Like the includes and the main and the function and now I got to go figure out why this compilation thing. It's just completely different. But yeah, Stephen, we'll throw it to you.
I think it was Paul Graham who said that a programming language should be like a pencil. It's for writing and thinking in. You published a blog post a few years ago in which you were using a calligraphy pen, if I remember correctly, and wrote your code in what I think you told me was Spencerian roundhand.
Yes.
I wonder if you could relate that to what you're saying about the process of thinking and creativity.
Well, I mean, so when it comes to connecting penmanship to coding, right, is I've always felt like pen and paper is powerful, right? And I think a lot of people in my generation have rediscovered the power of pen and paper. I would say, as a sort of pseudo Luddite in some sense, I never lost it. But there's an aspect of joy, like it goes this happiness, but there's also there's a deep-seated joy of working with your tools. And there's I think cultivating an environment in which you like what you're doing, you like what you're working with, and you can sense the beauty in it. I think that's a bit of an inspiring thing. And sometimes when you're working on things, you just need a little bit of that inspiration. You need that space. And when calligraphy, a lot of people will describe calligraphy as like sort of meditative. And so oftentimes I'll use a good, like, I've got my little Spencerian flex nib pen that I'll use, or, lately I've been working on a type of italic. So I've got this italic nib, I've got these different tools that let me experience a different type of handwriting. And when I work on that and I pick just the right kind of paper that has just the kind of feedback, you create a sensory experience for yourself that sort of helps get you in the zone, right? And so when I'm sitting there writing and doing these things, and just sketching out this code, it gets me into this free headspace. It's almost like you can do a type of Zen meditation, if you will, while you're coding. And so it's a way of it's a focus aid to bring your mind into this settled space while you're thinking about the code. And that, I think, frees up a lot of options. It lets you just sort of feel comfortable with the code. I think you memorize more of the code that you're doing. And I actually, this is something I haven't talked about a lot, but in any formal talk yet. I haven't been able to formalize it fully. But in my opinion, we pay way too much attention on externalized knowledge and not enough attention on the value of really, really deep knowledge. And you can see this, for example, in some articles that people talk about the ineffectiveness of group brainstorming. Like, people think group collaboration and brainstorming is the key to lots of innovation. But if you actually do the research and look at what these big companies did, like Google, I think, did a research on this and some other places, they found that in a lot of cases, this wasn't the case, that it helped occasionally for certain things. But a lot of times, the big innovations, the things that delivered the most value came from one individual sitting down and playing with an idea and then getting feedback from other people and then playing with that idea. And I think the part or reason for that was that the power of the individual comes in this really hyper efficient problem solving space, which is your internal mind. And the moment you have to externalize that thinking, you increase the communication overheads for processing and solving problems exponentially. And if instead you can internalize all of that deep knowledge into your brain in a way that it can work on solving the problems and making connections as you work with it, you've got this space that is really rich. And I think people have underestimated the value of the individual within the programming sphere, partly because of some of the Engelbart effect from Douglas Engelbart and his theories about this group cognition type stuff in computing. And I think that one of the aspects of writing on a pen and paper is the way it helps you internalize knowledge. And that internalized knowledge is the thing that allows you to then solve problems in ways that you wouldn't if you were just Googling and trying to find the right library and just working off of external feedback instead of your internal mind working over it.
Is aesthetics a big component in all this?
Aesthetic? Oh yeah, that goes back to the beauty thing, right? When you're creating something that's beautiful, it's a totally different thing than when you feel like you're creating something ugly.
I feel like this is a conversation which we're sort of like not supposed to have, programmers talking about beauty and so on, except we've found a way around it by pronouncing it cool. So in conversations with devs, you so often hear, "Oh, that's cool. That's really, you should look at this. It's cool."
Yeah.
So we're paying tribute to it. Well, we can't call it beauty or aesthetics, and I feel that while we use the term cool all over the place, we don't acknowledge the importance of it in finding out really good algorithms and beautiful ways of doing things.
Well, so okay, you've hit a point at which, if any listeners are highly sensitive, please tune out now, because I'm going to get into something that extends beyond the world of computing, which is that I think our society in general, in a lot of ways, has worked very, very hard to undermine the concept of beauty in a lot of ways. And so they've instead exchanged beauty for a variety of experience or something else. And I think that has a detriment on our ability to have ways of gaining deep and rich intuitive understandings of our world and our spaces. And so, for instance, art, one of the things that art can do is leverage beauty to bring out contrast and reveal some deep-seated human truth that people have a hard time seeing. And I think beauty can do that in ways that other approaches just can't. They fail because there are some things that we don't understand yet. And even in our very logical, very crisp computing world, there's so much we don't understand about ideas. And there's so much about the spaces in which we work that we don't understand how ideas are connected or anything. But when we apply beauty to that, we can set ourselves up for more serendipitous discovery than if we strip the beauty from a lot of what we do. So I actually think that beauty has a fundamental value proposition in delivering usefulness from a purely pragmatic standpoint, as well as from a psychological, emotional standpoint of making your programmers better and more ready to solve more difficult problems. But, so I think it's absolutely essential, but I think we are so used to disregarding beauty as a value. And when we do talk about things being beautiful, we've taken to calling so many things beautiful. We've used the wrong word for it, right? Because we've associated that nothing is worth anything if it's not utterly beautiful. Well, that's not really quite true, right? Beauty is an ideal that we look to as a guide that helps provide an anchor and a star, but that doesn't mean we now have to call everything beautiful so that we all feel worth something or something like this. And I think we've diluted the definition of beauty a lot in general use, as well as dismissing it in specialist use or very specific uses. And that the combination of those two things, I think, undermines our ability to leverage beauty intuitively, because I think we're trained against it in a lot of our social environments and societies, and especially within the computing world. If you're in a professional environment, I think there's still a little bit of that in the hobbyist environments and things like that, where you can still say, oh, this is beautiful. And if you go in a very like the mathematicians still, I think, are willing to leverage beauty in some sense, because their success depends on it in a sense, right? The elegance is almost a definition of the mathematician's space. And when you've got the computer scientists in academia that are fairly adjacent to mathematics in terms of what they're doing, I think a lot of that crosses over, and they start to be able to have this deep-seated aesthetic appreciation for elegance in the sense of beauty and that sort of thing.
As a piece of dialogue from Stephen Donaldson's 1981 fantasy, The Chronicles of Thomas Covenant, that always nails that for me. Central character Covenant's got projected into some other world where he's wandering around. And in conversation with a character there called Murray, he remarks that in this other world, he has a direct apprehension of the health, the vitality, the beauty of the environment. You can see it directly. You can see when the landscape of an ecology is healthy, and he wonders at that. Mm-hmm. And Morum turns to him and says, so you don't have that in your world? What do you have? Covenant says, well, we have something we call picturesque.
Yeah.
Morum turns directly to him, his face ashen, his expression horrified, and he says, how do you live?
I do think there's an aspect of that, right? I think a lot of people cut into their creativity partly because they undermine that aspect of their life, or they're living in an environment that pushes against that for them. And, I don't know that I have a solution for that. But I think in terms of how I choose to approach programming, aesthetics has a huge place to play.
Yeah, maybe I should make a compilation of a couple of clips from my podcast with Bryce. We can link them. They're honestly not the best podcast. We did a live coding in BQN, which is like the next gen APL by Marshall Lochbaum. And it's terrible because, like, I'm not even doing a good job explaining what we're doing. Like, I'm just coding, and then Bryce is like, what's that? What's that? And, like, we're not describing anything. But, like, at a couple different points, I just am like, holy smokes, does that work? And then I'm just like, oh, my goodness, this is so beautiful. And even Bryce is like, that is quite beautiful. Like, so there's these clips of, like, playing around. And it's so true. Like, I was coding a Python script the other day, and I needed to just print out the lengths of two different lists. And so you're applying a unary operation length to each list and then printing it out. And like in array language with combinators, that's just the psi combinator. You're catenating after applying tally to each one. And like going from like this sort of beautiful, what I think is beautiful, and then going to a language that doesn't support that, where now I have to spell with 6 different parentheses and, len, paren, insert list, print, and then another print. Like it's very hard. Like, so what Stephen, you're explaining, in this direct connection to the vitality of the land, it's like, oh, it's so wonderful. And then you come back to another language and it's like, oh, well, I can't express myself the way I want to express myself in that beautiful world. It just rings very true to me that it's not the end of the world, but just like constantly while I'm programming in other languages, as I'm like, well, this is in my head, I'm expressing it the beautiful way, but then I type out the less beautiful thing and just go, oh, well, I guess there's no other way to do this here.
I think joy has a big component of it, right? For me, programming has always been intimately connected with a sense of joy in what I'm doing, regardless of what I'm programming. And I've met a lot of people for which that's not the case. And it goes back to that whole picturesque. I sometimes have asked them, how do you live, right? How can you embrace the pain that comes with programming? Because it is a difficult art to do. How do you take that, and then without the joy that comes with it, how do you endure? And obviously they have their own reasons for doing it, but there have been times when I have advised certain students in our CS program to really, really have a bit of a think and a reflection over their reasons for being at the program, because they were miserable trying to do this coding stuff. And they were there because they thought that's what they needed to do to get the money. And that's just a recipe for a life of misery. And so, I think that's no way to get into computer science.
Yeah, my father always used to say, although it's a famous quote, but find something you love and you never have to work a day in your life. And yeah, I'm just lucky that what I loved happens to be in a very booming industry right now. Although APL, I wouldn't call that booming, but some would say that my
on a gentle upward trend.
Yeah, my bang for my buck on my my YouTube videos. It's like every once in a while I'll make something that's more clickbaity and what people want, and it's like 100,000 views, and then all my APL videos are like 500, 1,000. But it's that's what makes me happy. It's not about what my subscribers want. Yeah. But yeah, we've gone past a little bit the hour mark. There's a couple last things I'll say to round up the episode. But before we do that, are there any last sort of short questions or things we want to mention before we wrap things up? I'm seeing sort of head shakes. All right. So the things that I'll mention that we haven't gotten to. So if you have the time, Aaron, we'll definitely have you back at some point in the future. I feel, like what I said to Henry Rich is we had 1,000 questions and we got to like 4 of them. So we got 996 to go. At one point, you mentioned trees, and I actually had totally forgotten this, but a friend of mine, Joao, had asked us at ArrayCast to do an episode on sort of graphs in the array paradigm. And I said, we're actually having Aaron on. Probably we won't have a ton of time to talk about it, but maybe on a future episode we could dedicate, if not the whole episode, or at least a part of it, because I know that you've done a ton of work with sort of trees and graphs. Yeah. And that it seems like something that doesn't fit well with sort of an array or matrix model. But when you take a second look, it works fantastically. And I think even you told me that, or I'd heard in one of your talks that in originally a programming language, or maybe it was the second one, automated data processing, Ken Iverson actually dedicates like a huge portion of that book to talking about graph algorithms or tree algorithms. And at one point, even some of the Unicode symbols or glyphs, I guess they weren't Unicode symbols at the time, the glyphs were specifically had behavior that dealt with graph or tree algorithms or something. I'm not sure if you want to
Yeah, that's the original APL book. Yeah, the original APL book has a section on trees and has some discussion on ways of thinking about them. But yeah, the tree work, we should definitely talk about that at some point. But it is the one thing that the academic community was willing to recognize in a publication as worth novelty consideration. So it's sort of. It's sort of, I guess you could say, my contribution to the academic space at the moment is my work with trees.
Yeah, so we'll definitely have to have you back on, and we could also do a whole episode too. We didn't really talk about co-defunds much in detail, but maybe we'll do a deep dive on folks that want to hear about that. And last but not least, we currently, I'm not sure if we ever will, have a merch shop for ArrayCast, but instead of ArrayCast. While we don't have a merch shop, Aaron actually, and I was reminded of this when I went to your website recently, you do have a merch shop that is APL relevant. So I'm not sure if you want to plug or talk about, you've got, I think, 2 or 3 different sort of T-shirts, and I'm not sure if that you can order other things other than T-shirts, but I'm sure some of our listeners.
Mostly just T-shirts at the moment. Yeah. I like, if you go to sacredeo.us, there's a link to the shop, but the people kept joking about my research saying, oh, it'll fit on a T-shirt. And I was like, yes, it will. And so I made one. And so I made sure to, go around, and the T-shirts have actually made some public appearances and some things. I think one guy wore it to what looked like something like a EDM rave kind of thing, or something that he was DJing for, some kind of electronic music thing that he had up there. And so there's the symbols on there. I thought the aesthetic was quite good. And then I'm just like, there's some little, I like riffing on the idea of people like to put phrases on their shirts and make things. So I just translate the phrases into APL and make them little idioms. And it turns out that the translations work pretty well. So I've got 1 or 2 there. And then I have when you want to make a true religious statement and wear your, I guess your cross or your pentagram right on your chest, then there's the Quad IO Get Zero shirt.
That's right.
That, yeah. Make sure everybody knows where you stand on that. I maybe should also include like a Quad ML gets 1 or Quad ML gets 2 kind of thing.
Whoa, what's Quad ML?
Migration level. It's the way that you can convert dialogue to run in either the traditional dialogue APL sharp symbol set or the APL2 symbol interpretation, which switches a couple of symbols around.
So it's a flavor on either side of the APL2 versus sharp APL sort of.
Yeah.
Okay. Well, so exactly. Listener, if you've been thinking to yourself, what am I been doing with my life not wearing APL symbols on my T-shirt? We now have you hooked up, not with a merch shop that we've put together, but with one of our guests has. So, Bob, any last things you want to say?
Oh, just the usual. Get in touch with us, contact at arraycast.com, and we're love to hear from people. In fact, we've wanted to have Aaron on for an awful long time, but there have certainly been a few suggestions that we bring Aaron on through that, and now those people can be satisfied that we did listen and we were able to do it, and so everybody's benefited from that. And then also, show notes have been mentioned a lot. We really do work to put the show notes because a lot of what we're talking about can be so deep and I guess require a little bit of background. The show notes really help you. If you go in and you're not understanding something, go into the show notes because a lot of the background information is there. But as we were talking about a number of times, up front, this can be quite daunting. And if you do a little bit of background, actually, none of this is that difficult. But it initially appears quite impenetrable at times. But look at the show notes, see if they help you. If they don't, if you already know this, hey, just have fun. That's my message. Have fun.
Yeah, definitely have fun.
Everyone that was asking for Aaron can now, instead of stop emailing, they can start emailing, have Aaron back. But yeah, thanks so much for taking your time to come on Arraycast with us, Aaron. It's been a blast, and I always love chatting with you, whether it's at some conference in Gathertown or on some Zoom call for I think it was the New York J user group one time.
Yeah,
it's always a blast chatting, and well, that's the telltale sign that we got to wrap things up.
He's at the door.
All right.
It's the pizza. It's the pizza you ordered, Rich.
Well, it's been a ton of fun being on here, and I think this is I'd be happy to come back. It's always a blast. So
awesome. All right. With that, then we will say happy array programming.
Array programming.